Hello, pre-calc students. This is Mr. Bean. We're going to have a lesson today on reciprocal trig graphs. You see this structure here? It's kind of a weird thing. This is called a reciprocal structure. It has nothing to do with our lesson today, but it's just kind of cool because it says reciprocal. And here, let me show you something that you may have seen before. Not this one necessarily, but this last one is a reciprocal structure. And a really cool party trick with next time you're out with your family. At a restaurant, you could annoy everybody by grabbing their knife and putting your hands all over them and setting this cool thing up. Okay, that's called a reciprocal structure. Nothing to do again with the lesson, but it's still kind of cool because we're talking about reciprocal graphs. So let's remember what the cosine, sine, and tangent graph do. If you remember the cosine graph, it starts with a maximum value and then goes down. The sine graph starts at the origin and then goes up, and so it'll have a period of 2 pi. Same with this one. It'll have a period of 2 pi and then comes back to a maximum. And then the tangent graph, it goes through the origin, and every pi value, it will have a 1 period where it repeats itself. And then halfway to the period, you've got these vertical asymptotes. Okay, so we need to know what the originals were because now we're going to work with the reciprocals. So for the first reciprocal graph, secant, we're going to have cosine, 1 over cosine. So I remember this because the s and the c are going to go together for the cosine and secant. Now, it would be really nice if cosine's reciprocal was sine, but it's not. It doesn't work that way. So what you have to do is know that it's the other one. Cosine is 1 over secant, or vice versa, we have secant is the same as 1 over cosine. So why am I writing it out like this? Because what we need to do in order to graph this is understand when cosine is equal to 0. Because if we know when cosine is equal to 0, that creates a vertical asymptote when the denominator is a 0. So let's look at this right here. All these places where cosine is equal to 0, we're going to have a vertical asymptote for the secant graph. So on your graph for y equals secant, let's graph some vertical asymptotes at all of the zeros of cosine. And there's one more. Okay, once you have your vertical asymptotes down, then the rest of this is really easy. Because when we take the cosine graph, see where this max is right here? We're going to go up here to 1, put a maximum value there. There's our minimum value right there. Another maximum value. Because the amplitude of this is just a 1, so we're just going down 1. And right there, up 1. Okay. So before, when we graphed these things, we would just kind of make these waves and go through like that. Wait, that was pretty good, but that's not what we're doing this time. This is actually now a minimum, and it's going to approach these vertical asymptotes. So here, this is now a maximum, and it approaches the vertical asymptotes. That's what the reciprocal graphs look like. And that looks pretty bad. We're just trying to get sketches here. So the main point is get our vertical asymptotes in the right places and then have our min and maxes. And the min and maxes are connected with these of the sine and cosine of the reciprocal. So you would graph that off there. That is what the secant graph looks like. So you might have to graph the original cosine first. I'll show you that in an example in a minute. So get that one down. Oh, well, that was a mistake. Right here. See, that's what's nice about when you are teaching in front of the class and somebody's like, hey, Mr. Bean, you made a mistake right there. And then I can catch it before I keep going on. There, that's better. So that is the graph of our secant reciprocal. So let's go to the next one, which is cosecant. So again, if I have a C, it's going to go to S for the reciprocal. Cosecant goes to sine. Let's identify all the places where we have zeros because we want to figure out when does this thing equal 0. Because at those places of sine, when sine of x equals 0, its reciprocal will have a vertical asymptote. So here at negative pi, we'll have a vertical asymptote. At 0, over here at negative 2 pi, where else? At pi. And lastly at 2 pi. And it just keeps repeating that pattern over and over. All right, now let's fill in our max and mins. Here we have a max at 1 for pi over 2, so let's put a max. Then we have our min there. and our min here, whoops, need to do it at -1, and right there at -3π/2. And once you have your max and mins, this is the reciprocal graph, so it's going to approach these vertical asymptotes. And again, your sketch may not look perfect, but the idea is don't cross the vertical asymptote. Oh, that one's not supposed to go down, it's supposed to go up. There. So it's supposed to go away from where the graph would go. So on this, it would go up like that, and that's why this one's curving away from the original sine graph. Okay, and there is cosecant graph. Looks very similar to the secant graph, just like sine and cosine look very similar to each other. All right, the last one for the reciprocal graphs is cotangent. Now this one has a different period. So let's remind ourselves, and I could have put that on these too if you want to go back. You could say that the period of this is going to be 2π/b. That's the period, just like what we did before. This one again, the period for this one is 2π/b, so it fits with sine and cosine. But this one is going to fit with tangent, and so therefore it is π/b for its period. Okay, bloop. Let's do the same thing. When does the bottom equal 0? That is going to create our vertical asymptotes. So it's got a 0 there, and there, and there, and there, and there. All right, what else? So we take those zeros, that's going to create a vertical asymptote on this graph down below, because we can't have 0 in a denominator. Okay, vertical asymptote, vertical asymptote. And last one. Okay. So what do we do with that? Okay, so tangent is going to be, or cotangent, excuse me, you just find the middle of the vertical asymptotes. That's where it's going to be the middle. Bloop, bloop, bloop. And this graph goes the opposite way, like that. So it's going to go the opposite way, the reciprocal of what tangent would do. So they look kind of similar. There we go. And just like tangent, if you want to know halfway between this x-intercept and the vertical asymptote, that dot right there, that has to do with the amplitude. Since the amplitude here, the number's a 1, so we go over 1, up 1. That's how we know, over 1, down 1. Just remember, it does the opposite of what tangent does. Tangent will be going up. This one will be going down as you move left to right. Okay, let's practice this. We have some examples here. So I call it amplitude. Technically, it's not really amplitude, but you have to be able to know what the graph of the original sine, cosine, tangent, all that is. So first, focus on cosecant. Cosecant is going to be the reciprocal of 1 over sine. So we want to focus on what the sine graph would look like originally. The amplitude is just a 1. The period is 2π/b. B is a 1/2, and therefore our period is 4π. The vertical shift, it's not shifting up or down at all, so I'll just put that there is none. And then the phase shift says we're going left. How far? We're going left π/4. Okay, let's figure out where this stuff is going on. Let's first look at, I'm going to have to do this lightly in a pencil because we're going to make a little bit of mistakes or have to shift some things. Sine graph. Don't even worry about the phase shift left. Let's just think sine graph goes through the origin. And then what? We're going to go 4π, out 4π. Well, I can't go all the way out 4π because it doesn't have enough room here. It only goes to 2π. So sine is usually going up like that, where it's going up. So if I went out 4π, it would be going up again. Therefore, here it's going down, which means halfway between, it's got my maximum value right there. So let's sketch that. Here I have a vertical asymptote. Here I have a maximum. I say vertical asymptote, wherever the zeros are. Here's another 0 down here. So you have to be able to graph what the original sine graph would look like. And now let's shift all of these points. So this is why you probably needed to do it lightly with a pencil, because then we're going to shift them π/4, which on my grid is only one line. That's how I shifted it π/4. Or for you, if you wanted to put your little marks like we did in the last lesson, put your little X's or something like that. That might help as well. Okay. Then let's graph our vertical asymptote. So any place we had a 0 for sine, we now have a vertical asymptote. So there's a vertical asymptote. It is off my grid, I know that. And then there is a vertical asymptote. Okay, from here, really, really simple. We just grab this maximum value. It now becomes the minimum for the reciprocal graph, and it does something like this. And this one is approaching down. And again, we're just trying to sketch a basic shape of what this graph looks like, and that's it. Okay, let's do another one. Secant. Secant is the same thing as 1 over cosine. Let's factor this out. We'll rewrite it so it's -2 secant, and then I'll factor out the 2, so that becomes x minus pi over 2. I'm dividing by 2, so that's why it's a pi over 2, and then minus 1. All right, the amplitude then is a 2. The period is 2 pi over b, which in this case is a 2, so the period is a pi. Vertical shift, I'm going down 1, and then the phase shift is right pi over 2. Whoops, pi over 2. Okay, so grab our equilibrium point. Instead of it being right here on the x-axis, it's shifting down 1. So there's my equilibrium values now. And I'll go ahead and put some little tally marks to help us know where we are going to be before we shift it with this period. So cosine graph. The cosine, we're doing the reciprocal of it. Cosine would start with a maximum typically, which we would be up 2 because of the amplitude, but it's a -2. So we got to go down to, I'll put a little x there because we're going to shift it. And then the period is pi, so if I come out here to pi, it would be down at a minimum again. Down at a minimum. So go every pi, and it's repeating. That means halfway between these values is going to be a maximum. So I'll go halfway between all the minimums. And then halfway between the mins and maxes is going to be where we have our x-intercept. Or for our reciprocal graph, that's where we have our vertical asymptotes. But don't forget, we are going to have to shift all of these. So you didn't have to put as many as I did. I'm just putting those down there. Make sure we see the same thing. Now we're going to shift it right pi over 2. So pi over 2 is an entire 2 lines. So we shift the whole thing 2 lines. So let's go here, here, here. All the x's are just going to be on top of each other, the x-intercepts here. And where's this one going to be? Here. We're shifting everything right pi over 2. Doot. And I think that's it. Oh, this one will be right here. Okay, now we can graph our vertical asymptotes. There we go. So again, these vertical asymptotes, the x-intercepts for the cosine graph, they shift right pi over 2, which means they just kind of overlap on each other. And so, and there. And as you're doing this, and we're about to sketch the next part, these the mins and maxes of these branches, don't forget that we're not looking at the blue lines. In fact, if you did it really lightly, if it helps you to erase them, if that helps to get rid of those, because we're focusing on the blue ones here, we're focusing on the red ones, not the blue ones. And now we just fill in the rest. There we go. Sketches up, down, and that is the answer to number 2. Okay, hopefully you're okay with that one. It's kind of difficult because we are throwing everything at you that we learned in the last 2 lessons, and on top of that, doing the reciprocal graphs. So we're having to shift it up, down, left, right, phase shifts, all that stuff going on all at once. All right, let's try number 3 with the cotangent graph. So first, remember, this is the reciprocal of tangent. We need to rewrite this, though. Let's rewrite this as cotangent of 1/2. So we got to pull out that 1/2, and then we get x plus. So what does this become? If you're dividing by a half, it's the same thing as multiplying by 2. Whoops, that becomes 4, pi over 4. So again, if you're dividing 1/2 out, dividing by a half is the same as multiplying by 2. So that means the phase shift is going to be left pi over 4. All right, what's the amplitude? Amplitude is just a 1. The period is 2 pi. No, not 2 pi. It's cotangent. Be careful. Be careful. It's just a pi over a half. Well, pi over a half is the same thing as 2 pi. Dividing by half is the same as multiplying by 2. And then the vertical shift, there is none. We're not going up or down on this. All right, so if you can remember tangent, tangent is right there at the origin, if you remember that one. And then we will be repeating every 2 pi for this example. So that's where tangent graph is, which means the cotangent, its reciprocal, that's where the vertical asymptotes are. Wherever the x-intercepts, that's the vertical asymptotes of the reciprocal. Okay, and then this one's pretty easy to sketch because you just have to remember what the shape of it looks like. Halfway between, we're going to have our real x-intercepts. And then halfway between those, remember that cotangent graph does something like that. But to make it a little bit more accurate, we use the amplitude A. So we come over here halfway and down 1. And then over here halfway to the vertical asymptote and up 1. And then you can kind of just a little bit more smoothly sketch what that graph looks like. So here down 1 and here up 1. And again, so it's just repeating itself. Whoops, missed that dot, but that's all right. Okay, so this is the last problem. I want you to try this one on your own. So go ahead and pause now, give it a shot, and I will have the answer appear. And there's your answer to number 4. I'm going to explain this real quick, but don't forget, if this is confusing for you on number 4, don't forget to ask your teacher some questions about this. Your classroom teacher can help you. All right, so here's how this worked. It was a reciprocal of sine. So what I started off with was that it was a vertical shift up 1, so I shifted the thing up 1, and then I figured out that this was the x-intercept, or my equilibrium point, the new one, because of the sine, and then I shifted it at 2 pi, so I went out 2 pi and repeated it. So I knew that sine, if I were to do it in red, the sine graph was going something like this. That's what the sine graph was doing, but I had to shift it left pi units, so I shifted the whole thing left pi. That's where the blue is. The blue is the answer. So I could really get rid of these tally marks here, because really the blue one is my final graph for secant. All right, this is Mr. Bean signing off. Rock that master check, and I'll see you back for one more lesson in this unit.